Hello and welcome to our video on logarithm laws. The main thing we need to remember before we look at the logarithm laws is that each law we're going to look at using today relates to an index law. And that's really important. I've put that in green and I'll be putting the index laws that relate to each of these logarithmic laws in green underneath them as well, so you can see that really clearly. Just a reminder before we start that log 10 of 10 equals 1 when we have the base and the number the same. It's like doing the inverse, taking the logarithm and taking a power. So that always equals 1, and the reason is right here, because exponentials and logarithms are inverses of each other. Okay, moving on to the laws. The first law that we've got here states log to the base a of m plus log to the base a of n equals log to the base a of m times n. Now all this stuff down the bottom here is just some information for you. M and n must be greater than 0. So they need to be positive numbers. A needs to be a positive number and A can't equal 1. So your base can't be a 1 and pretty much all these numbers need to be positive for this law to work. You can check this law really easily on your calculator, and I'd like you to pause the video now and just work out what each of these sections equal. This is the left hand side of a problem, this is the right hand side of a problem, and hopefully they should be equal when you do them on your calculator. Pause the video now, please. Okay, hopefully you've had a minute to have a go at checking on your calculator. You don't even need a calculator for this first one. Log 10 of 10, when the base and the number are the same, it equals 1. And we've got log 10 of 100. You could put that into your calculator and you should get a 2. 1 plus 2 equals 3. That's the left hand side of a problem. And if we use our first law here, which would be, because the bases are the same, log 10 and log 10 here, we can, and we've got a plus in between, here's our plus, we can make it m times n. So 10 times 100, that's why I've got here 10 times 100, still the same base, log 10 of 10 times 100. Put this all into your calculator and you should get 3, which is the same as the 3 we came up with here. So that's showing you that these two sides and that the law does work. If you're ever not sure if something works, it's really useful to put both sides of the problem and how you're thinking of simplifying it into the calculator to see if you get the same solution or not. What I'd like to do now is give you another quick example of this first law. So I've got here log 10 of 200. Sorry about that, it's a funny looking 0. 200 plus, would need to have a plus to fit this law, log 10 of 5. That's our problem and we're trying to simplify it. So the first step I'm going to do here is multiply the 200 by the 5, keep the same base, log 10 of 200 times 5 is the same as log 10 of 1000, which we can rewrite as log 10 of 10 to the 3, and using that law that we had up here, log 10 of 10 is 1, or any two numbers that are the same. So this whole thing cancels to be 1, and we're just left with 3. So this whole problem here simplifies to 3. I just want to add up here in green the index law that this is related to. You might have already picked up on it, and it's related to the index law that says a to the m times a to the n equals a to the m plus n. So it's kind of the reverse. You plus the powers here when you're multiplying them. Here, when they're plussed, you multiply the logs. They are related though. Law 2 says log to the base a of m minus log to the base a of n equals log a m divided by n. That is of course related to the index law. A to the m divided by a to the n is the same as a to the m minus n. An example here for you. Log 2 32 minus log 2 of 8. Again, before we do any of these, use any of these laws, we need to check to make sure that these little powers, bases, are the same number. So here we've got log 2 and here we've got log 2. They're the same base, so it means we can use one of our log laws. We can go straight into log 2 32 divided by 8, which is the same as log 2 of 4, which we can further simplify. 4 is the same as 2 squared. And then we've got this same thing that happened here where the base and the number are the same. It equals 1. So log 2 is 1, and we're just left with this 2 here. So it just equals 2. So this whole thing here simplifies to 2. And if you put that into your calculator, you should get 2 as a solution. Law number 3 says log to the base a of m to the power p is the same as taking the power out the front here. So you can see p is here out the front of the whole logarithm, and we just leave the rest of it the same. P log to the base a of m. Same rules that we've had all along. M must be positive, a must be positive, and a can't equal 1. The index law that this one relates to is this one. And an example here, you can use this one, we often use it either way, either moving from this version into this version, or from this version and rewriting it into this way. So I'm just going to go one way for our example. Log 5 of 9 is the same as log 5 3 squared, which is the same as 2. That's a weird looking 2. 2 log 5 3. And that's the most we can simplify this one. Just make that equals look a little bit clearer. Now I also wanted to highlight for you just over here, I'll just put this in a separate box. What if there's no base? For example, you might get a problem that just says log 36. And you go, hang on, there's no little base here. How am I supposed to work that out? No base means log 10. So you can use that shortcut. If you're writing log 10, you don't need to write the 10. You can just write log. Otherwise, for all other bases, you need to make sure you write the log. So just keep that in mind if you're doing a problem that has no base, it means log 10. Fourth law that I have here, and then these are more like identities. Log A to the A equals 1. We said that one right at the start because the inverse of a power is, they're the opposite of each other. So it equals 1, and log A to the 1 always equals 0. This one here is related to the index law, A to the 0 equals 1. And this law 4 is related to the index law, A to the 1 equals A. Anything to the power 1 equals itself. Okay, I'd like to give you a minute now to have a look through some of the examples I've got on this page and the very next page. And I'd like you to have a go at using all of the 5 log laws that I've given you to try and simplify each of these problems, to simplify them down to the most simplified that you can. If you're feeling confident when you've finished the problems and you only want to check your solutions, you're welcome to just go straight to the class notes that are on the intranet page. If you are interested in watching the video worked solutions, please have a look at the next video, log laws examples. Otherwise, thank you for watching.